All right, so in explaining the shape of the periodic table, what should you have on here? What do you need? Um,
How well I want to give up its other electrons.
nope. So organized based off of columns or families um, based on similar chemical reactivity. You shouldn't say anything about electrons here. Why? Say it one more time. And even after he knew about it, he didn't believe it. The guy who made the periodic table knew nothing of electrons, did not believe electrons existed even after they were discovered. So I agree that the similar chemical reactivity is because of the electrons, but he had no idea what electrons were. So it was really just based off of similar chemical reactivity. Why did it work out for him? Second half of definition of chemistry. Because reactions happen because of electrons. So yeah, it needed to work out for him. It had to. Family. What is a family? Why is the lithium and the fluorine? Why are those guys both reactive? They're both trying to do the same thing, right? Ultimately, they're trying to change one thing. So gain or lose one electron. If I only have to do one thing, then I'm going to violently try to get that done. So I'm going to try to get rid of one electron if I'm lithium, or I'm going to try to gain one electron if I'm fluorine. All right, so how does something become a cation? Loses. One or more electrons. All right, so choose an element that wants to become a cation and tell me what charge it's going to make. So somebody pick an element. So I have the lithium element, and it's going to turn into what ion? Li plus. How do you know that? It loses one electron. It's in the first column on the periodic table. When you look at its oxidation state written on the periodic table, it's got a 1 written there. So that's letting you know that its charge is going to be a +1. All right, anion must what? Gain. So what do you want to put in here? Fluorine's in the second to last column, the halogen column, and then in that column, the elements want to gain 1 electron. And if you look on the oxidation state listed for fluorine, it says -1, so 1. Metals and nonmetals differing. So we've got luster, malleable, ductile, conducts heat, conducts electricity, Mostly solids. Am I forgetting anything? Oh, make alloys. Anything else? Can't think of anything else off the top of my head. And non-metals. Doesn't do any of that stuff. So they are not shiny. They are not, you cannot pound them into anything. You can't pull them into a wire. They don't conduct heat or electricity well. They're not mostly solids. They're mostly gases. There's a liquid in there too. And they cannot make alloys. Total number of protons and electrons in a phosphate. So what's the formula for phosphate? P O4 -3. Okay, so a phosphorus has how many protons? 15 protons. And an oxygen? 8 protons times 4. All right, so there's 32 and then 15 to that, so that's 47 47 protons. These 5 atoms have 47 protons. How many electrons are here? 50. There's 47 electrons absolutely for sure, because there's 47 protons. And this is telling you that there are 3 more electrons that this thing would have if everybody was an atom. So together, those 5 atoms have pulled 3 electrons away from something, and it doesn't matter what. So then I'd add this 3 to my 47, and I'd end up with 50 total electrons. We're going to talk about the naming stuff today, but a lot of these are, the ones I gave you were pretty simple. So what's this first one? Lithium chloride. And the next one? Chloride. And the next one? The next one? Sodium. Potassium. Two things. Every single one of these names ends in an "ide." That's going to be important to us. And then why is the ratio 1-to-1 for each of these compounds? Say that first part again. These elements are what? They're all in the same family, right? And these elements are all in the same family. So they have similar chemical reactivity, meaning I can swap any halogen out in that spot right there, and this would be the same formula. This lithium plus whatever halogen. And I could do the opposite. I can leave the chlorine here, and I can put any one of the group 1 metals in here and have the same ratio, 1-to-1 ratio, because they're all trying to do the same thing. And I know that because their chemical reactivity is the same, because they're all trying to do the same thing. Okay.